Hello, well, welcome back to another video. It's been a while since the COVID spring, and I haven't cut my hair since then, and I'm going to add another video about set 17, problem 3. That's a 2x2 system of ODEs with complex eigenvalues. The matrix here, A, has eigenvalues plus or minus 1, which we computed in the previous video. I'm doing another video because that video I did before in this problem, that was 17 minutes and 35 seconds, really long. And I did, I was going kind of slowly to explain everything, but I've got a much quicker and easier method to solve systems like this with complex eigenvalues. And I put it in a PDF that's on our website called System Solutions. And I have version 1 and version 2, but this is version 1. They're almost the same. And it has this in the box. It tells you what to do. It's a cookbook formula about how to find the solution to the initial value problem. Not the general solution, but the solution to this initial value problem. Okay, so let's go on in. We've found before that the eigenvalues are plus or minus I, so we can just carry on here. Since the eigenvalues lambda 1 is I, that's 0 plus 1 times I, lambda 2 is 0 plus 0 minus 1 times I. So we have A is 0 and B is 1. By the way, e to the 0t is just going to be 1 in this case. So in the solution, I can just ignore that prefactor of 1. But I need to compute x1. Remember, this is the vector x1 as opposed to the first component. The vector x1 is A minus 0I x naught, because little a is 0. So I can just ignore that. That's just ax naught. And so what in this case, that is a negative 1, 1, negative 2, 1 times negative 3, 1. That is what, 3 plus 3. Well, I think, sorry, there's a minus 1 here. That's a minus 1 in x naught. That's plus 3 minus 1. That's plus 6 minus 1. I compute that as 2, 5. So x1 is 2, 5, and that's what goes right here. X naught, the initial condition, is negative 3, 1. That goes here. Cos B is 1, so the solution, we can go right to the solution, is x of t is e to the at, which is 1. I can ignore that, times the vector negative 3, negative 1, times cos t. It's just cos t because b is 1. And then I have plus 2, 5 times 1 over b, sine bt, but b is 1, so this is just sine of bt. All right, so that's a nice way of writing it, but I think we can just go straight to the solution because I can do the addition in my head. So this is going to be minus 3 cos of t plus 2 sine of t. Oh, that's not bt, that's b is 1. Plus 2 sine of t, then I get minus cos of t plus 5 sine of t. Okay, so that's a lot quicker than the other way, I think. But it gives us the same answer, of course, as unless we made a mistake, but I think I did it right. The same answer as the other method of finding the eigenvectors. Remember, I had 3 steps. Find the eigenvectors, multiply e to the lambda t times v, and everything is complex. You have to take the real and imaginary part, get the general solution, plug in the initial condition, find the C1 and C2 in the general solution, plug it back. This is about 50 times faster. All right, hang in there. Yeah, if I had known it was this easy, I would have given you more problems. This homework set only has 1 example with complex eigenvalues because I thought it'd take so long to do it. But with this system, you can do them like a snap. All right, bye.